Today I'm tuning the memory timings of my G.SKILL EXPO-8000 32GB memory kit. Hello and welcome to Checkpoint, a video series where I cover specific overclocking topics in a much shorter format. In today's Checkpoint, I want to show you how I went about tuning the memory timings of my G.SKILL EXPO-8000 kit, which I used in OC strategy number 3 of my 9950 X30 SkatterBencher overclocking guide. Tuning the memory timings helps improve the system performance in workloads that depend on fast or high bandwidth memory like AI Benchmark, Y-Cruncher, and even Geekbench. After tuning the memory timings, my AIDA64 bandwidth was around 100 GB per second with sub 67 nanosecond latency. AMD Extended Profiles for Overclocking, or AMD Expo, enables ubiquitous memory overclocking profiles for AMD platforms supporting DDR5 memory. Its purpose is to allow memory vendors to program higher than JEDEC performance profiles onto the SPD of memory sticks. The user can then enable these settings with a single option in the BIOS. The result is that customers can unleash their full memory performance with essentially the click of a single button. Generally, I find that Expo is a really quick and easy way to improve the memory performance. And most of the time, it just works out of the box. You can enable it in the BIOS and it just works. Sometimes, however, it doesn't work, although that has more to do with the memory controller voltages and frequencies rather than the kit itself. Do note that an Expo kit doesn't offer maximum performance out of the box, and it's obvious why. Memory vendors have to make sure that the Expo profile works with a broad range of memory kits that they're producing with that spec. So they have to be a little bit conservative in certain timings or frequencies. However, that variation is something that we can exploit as performance enthusiasts. There are a lot of memory timings, however, and the topic of memory controller and system memory tuning is exceptionally complicated. It's not really an option to first get a deep understanding of memory controllers and memory ICs and then applying that knowledge to memory tuning. The fastest and usually the most effective approach is basic trial and error. Fortunately, motherboard vendors help us out, providing some guidance on how to tune the memory timings. ASUS Memory Presets is an ASUS overclocking technology that provides a selection of memory tuning presets for specific memory ICs. The presets will adjust the memory timings and voltages. The ROG Crosshair X870E Hero motherboard sports 14 memory profiles for a variety of memory ICs and configurations. Since we're interested in adjusting the memory timings, we can try the Hynix 7600 MHz 1.45 volt 2x16GB single rank preset. Testing for memory stability is a bit of a hot topic in the enthusiast community because different communities will have different yardsticks to determine what's stable. I believe the current meta is using the Karhu software, but it used to be Memtest. I would recommend watching Bultoid's YouTube channel if you want to keep up to date on what's new in the memory overclocking community. I've always relied on the OCCT memory stress test because, well, I also use OCCT for CPU core stress testing. I always found that if the memory passed 1 hour of OCCT, it never really failed any benchmark or other workloads. One exception is the TRAS sensitivity for AMD iGPUs, but that's a whole different topic altogether. Since the OCCT memory stress test has always worked for me, that's what I'll stick with. But if you want to use a different stress test, that's okay too. Stability means different things to different people. It was the first time that I used an EXPO-8000 kit with an AMD Ryzen processor, so I had to start my tuning journey from scratch. The Hynix 7600 memory preset turned out not to be stable, as it would throw errors in the OCCT memory stress test almost instantly.
An error has been detected.
To fine-tune the timings, I wanted to move some of the timings back to the Expo configuration to see which ones were causing the error messages. To speed up the process, I grouped together the following timings. By checking the impact of adjusting each group's timings, I found that it was the L and S suffix subtimings of group 5 causing memory instability. By relaxing them just a bit, the memory was stable. Here are the final optimized memory timings for this memory kit. After the tuning, our AIDA64 performance improved quite significantly. We got about plus 50% extra bandwidth and plus 25% better latency by enabling Expo. The memory tuning then added another 12 to 15% on top of that. Of course, this is not where our tuning journey ends. There's probably some subtimings that I could further tighten up and get even more performance. And that's exactly what I would do if I was trying to set benchmark records or was participating in an overclocking competition. But I'm not. This was just for my overclocking guide, and it's intended as a daily configuration. And this was already work enough. Anyway, that's it for this checkpoint. Thank you for watching. Let me know if you have any ideas in the comments below, and see you next time.